All right, now to get into some larger examples, we are going to look at how to find the data value using the inverse normal distribution. So this is our same normal distribution, but now we know the probability, and we're going to essentially work backwards to find the data value or the X value. So the steps we're going to follow in this process, where we're being asked to find the X value, are starting out, we're going to draw the curve, and that's such an important step that it gets a whole step by itself. Draw the curve. Then you're going to shade the approximate area based on the given probability. Then we're going to use Excel to find the z-score that correlates with that given probability. And then we're going to use the z-score to solve for x using the x equals equation. So the example that we're going to be working with in this problem says the weights of newborn giraffes are normally distributed with a mean weight of 125 pounds and a standard deviation of 15 pounds. So from this, we need that the weights are normally distributed. The mean weight is 125 pounds and the standard deviation is 15 pounds. So we need to know that it's normally distributed, otherwise we cannot do the 4 steps that I just went over, because these only work for things that are normally distributed. We need to know that mean weight of 125 pounds, and we need to know that the standard deviation is 15 pounds. So that's a good start. So question A, part A, find the weight of the smallest 60% of newborn giraffes. So find the weight. So we're not finding the probability now, we're finding the weight of the smallest 60% of newborn giraffes. So this is the area to the left because they're the smallest 60%. If you're small, then you're going to be on the left side of the curve. So step 1 is just draw the curve. And I've already put a curve in here for us to use. But if you don't already have a curve, then you want to make sure that you draw it. And I'm going to add a line down the middle and put a 0 here for the z-score of 0, just because that's a really nice reference point. Now, one of the things that's important to remember is the area up to that middle line is 50% of the curve. And then from the middle line to the other side, that's 50% of the curve. So that's also important to remember as we move into step 2, which is to shade our curve. Now we're going to shade our curve based on the area we've been given. So it says find the weight of the smallest 60% of newborn giraffes. So the probability or the area that we were given was 60%. So that is how much we are going to shade. So because it's 60%, I know that when I go to shade my curve, I am going to have to shade more than half of my curve, no matter where I start. I also know the smallest means that I want my area to be to the left eventually. And I also put, in this particular example, area to the left. So what that means is wherever I stop shading, I want the area to be 60% to the left. So the way that I particularly do this is not the only way to do this, is I start my shading on the left side of the curve. So I'm going to come over here and I'm going to start on the far left and I'm going to shade and I'm going to keep going. And when I get up to this line, that's 50%. I need to go to 60%. So I need to shade about 10% more, which is not that much. And then this is where I'm going to stop. So I'm going to draw a straight line down. And this is where my z-score is. And I don't know what my z-score is right now, but I know that it's right here. So to me, this looks like roughly 60% of my curve. It's not perfect, but I know that 50% would get me to the middle line, and I needed 10% past that. So I went just a little bit further. If you remember the empirical rule, from the middle to 1 standard deviation, that was 34%. So I don't want to go too far past the middle because most of the graph is in this middle section. So I just went a little bit past. Try to kind of think about those percentages from the empirical rule as I'm going. So now I have where the z-score is. Everything to the left of the z-score is shaded. That's what I wanted. So now I can go to step 3, which is to use Excel to find the value of this z-score. So I'm going to write out what I'm going to do in Excel, and then we'll go into Excel and actually find this value. So in Excel, we're going to start with an equal sign, and then the function that we're going to use is norm.s.inv, because we're doing the inverse. We're doing the opposite of what we were doing before. Before we were finding the probability, now we are using the probability. And I'm going to open parentheses, and then the only thing that I have to put into norm.s.inverse is the area to the left of the z-score that I'm trying to find. So the area to the left of my unknown z-score is 60%. That's what we shaded. Excel cannot work with percentages, so I have to put it in as a decimal. So when I go to Excel and I put all of this in, the result is going to be the z-score that corresponds with where I stopped. So I'm going to pull up Excel and make sure that everything is connected. There we go. Norm. Oh, I forgot the equal sign. If you forget the equal sign, Excel doesn't know that you want to calculate anything. Norm.s.inv 0.6. We don't have to do true because if you're doing this, then you've got a shaded region. And we hit enter, and that is the z-score, 0.253. So I'm going to go back, oops, 0.253 is the z-score right here, 0.253. So if you've shaded 60% of your curve starting from the left so that the area is to the left, then your z-score is 0.253. 60% of the normal distribution to the left of 0.253 are those correlate. Those go together. And so the last thing that we have to do is solve for x. Our x equation is z times sigma plus mu. So our z-score is 0.253 times our sigma is 15 and our mu is 125. So 0.253 times 15 plus 125. 128.795, and we have a unit on this answer because it represents the data, and it was a weight, and our weights were given to us in pounds. So 60% of newborn giraffes weigh less than 128.795 pounds. So that is how you calculate the data value when you have been given the probability to the left using the normal distribution and Excel.